And my name is Gaurav Gupta, your faculty for geography. So in today's session, we are going to discuss about the heat budget of the Earth. See, heat budget of the Earth is a very important equation between the incoming solar radiations, which is Earth is absorbing, and the outgoing terrestrial radiations, which Earth is releasing. So basically, let's start the session. If there is any kind of discrepancy, any kind of anomaly between the incoming solar radiations and the outgoing terrestrial radiations, that is the radiations which have been released back by the Earth, so that will lead to serious problems. There will be problem of global warming, climate change, and so on. So let's start a session. So basically, this is the topic of heat budget. So here you can see that there is an equation. There are certain radiations which are being absorbed by the Earth. Okay, let's say for example, let's start here. So let us assume the heat budget of the Earth is basically an equation between the incoming solar radiations and the outgoing terrestrial radiations. So let us assume that in total, the Earth receives 100 units of solar radiations on a daily basis. Let us assume that Earth receives 100 units of solar radiation on daily basis. Out of these 100 units, there are 35 units which are basically reflected back by the Earth without being absorbed. These are the 35 units which are being reflected back by the Earth without getting absorbed. How they are reflected? So basically, here we have some clouds. These are some clouds. So around 27 units are reflected back by the clouds. 27 units are reflected back by clouds. Then our Earth has several glaciers also. So around 2 units of radiations are released back by Earth. And we have lots of dust particles in our atmosphere. So from these dust particles, around 6 units of solar radiations are reflected back without being absorbed by the Earth's surface. This mechanism is known as albedo. So by the mechanism of albedo, 35 units of these solar radiations, they gets reflected back by the Earth without getting absorbed. So 100 minus 35, that means now we are left with 65 units. Of these 65 units, 14 units are absorbed by ozone layer. 14 units are absorbed by ozone layer. Now remaining 65, then minus 14, then it will be 51 units. So these are the 51 units which are being sent to Earth. Of these 51 units, they will be absorbed to the Earth's surface. So in total, there are 51 units which are being absorbed by the Earth. Now, we'll be seeing that what Earth will be doing of these 51 units. Like for example, if your parents give you some money, some pocket money kind of thing, so they will be definitely asking that what you have done with that pocket money. Maybe certainly they will be asking some questions. Yeah, I think it's a very normal thing, right? So we'll be also checking out that what Earth is doing with these 51 units radiation. So basically, of these 51 units, 19 units are basically used. 19 units are basically used for the purpose of evaporation, condensation, and precipitation. So of these 51 units, Earth will be consuming 19 units for this purpose: evaporation, condensation, and precipitation. Then 9 units will be sent 9 units will be sent back directly in the form of convection heat. directly in the form of convection heat, and then 6 units will be absorbed as they will be absorbed by the greenhouse gases like carbon dioxide, water vapor, all these things. So in total here you can see that 19 plus 9, that is 38, and 38 plus 6, that is 19 plus 9, that is 28, and 28 plus 6, 34. So Earth has utilized these 34 units. Now remaining 17 units. So the remaining 17 units basically, these remaining 17 units, they will be sent back directly to the outer atmosphere in the form of terrestrial radiations. In the form of terrestrial radiations. So here you can see the total amount of radiations which Earth has received, the same amount of radiations it has released back. It got 100 units, it sent back 100 units. But whenever there is an imbalance between the incoming solar radiations and the outgoing terrestrial radiations, then it will lead to chaos in the entire environment, in the entire geographical setup. What happens? Let's say, for example, in the present scenario of global warming, this problem has occurred because of excessive emission of carbon dioxide. So this carbon dioxide is a greenhouse gas. It is the heat absorbing gas. So it is transparent for the incoming solar radiation, but it is opaque to the outgoing terrestrial radiations. So more and more, whenever there is more and more concentration of carbon dioxide in the atmosphere, this will lead to absorption of more and more terrestrial radiations. And when the Earth will be absorbing more and more terrestrial radiations, this will lead to more and more warming of the Earth's atmosphere. This will lead to melting of glaciers. This will lead to melting of ice caps. This will lead to rise in sea level. This will lead to floods in the mountainous regions, and so on. Even the problem of El Nino, La Nina, it is also the gift of this problem only. I hope you have liked this session. Thank you so much. Bye bye. Take care.